Hello everyone. So this is a AI problem that given a grid based mesh where 0 represents walls and 1 represents walkable paths. Find the shortest path from a start cell to an end cell. Use BFS to find the shortest path. Use DFS to explore all possible paths and report one valid path, not necessarily the shortest. Compare the number of nodes explored by BFS and DFS. So let us see. Now this is my Python code where I am using this class mesh path finder, and I am creating a mesh where 1 represents the walls and 0 represents the 0 represents walls and 1 represents the walkable path. So this is my starting point 0 0 and this is my end point. I have to move from this point to this point where 0 is my wall blocking path and 1 is the path I can move. So 1 is a valid path, walkable path, and 0 is the wall. So now I create a graphical user interface through these frames and grid buttons, and I create a visual representation of the mesh. Then I color them. I make it white to represent the walkable paths and the black one represent the wall. So the moves that I make are up, down, left, right. So first of all, the BFS breadth first search, in which I create a queue, and if the queue is empty then no path found, or else xy is my current point that is being tracked, and path represents the path traversed. So now if I am exploring some path or some point, then it is marked as yellow. If it is reaching the end point, then I am visualizing that path. So these are my possible moves: right, down, left, up, and I am inserting in the queue the if some visited or explored nodes, then I am starting the breadth first search visualization. So similarly, I am creating a depth first search in which I am using the stack, and xy is the current node being processed, path is the path traversed. So I am making this purple color to the visited nodes apart from start and end button, and then if it is reaching the end, I am creating the visualize path. Then similarly I am putting all the explored nodes onto the stack in case of depth first search. So for the visualizing the path I am coloring it as blue. So this is my mesh pathfinding visualization. Now let us run it. So now you can see this path. So I am getting the path explored nodes as yellow and the shortest path as colored in blue. So the path length found is 13, explored nodes 15. Similarly, for DFS path finding, So now let us see one more example where the mesh is created randomly. So now we can see, if I run it, this is the mesh which is created randomly. Now suppose I am trying to find the BFS path finding, then it will say no path found, as the other cells are the walls. So I'll regenerate the mesh. Now this also will generate a. Now let us see here the BFS path finding. So it is exploring all the neighbor nodes and marking it as yellow. Saying no path found. Let us see through DFS. DFS also is saying no path found. So maybe if I do it once more, let us see. No path, although it has explored all the nodes, still there is no path found, because this it cannot go diagonally. Because of that reason, this endpoint is inaccessible either through BFS or DFS. So let me regenerate the mesh, because since there is no diagonal movement, so it will generate a no path found. So let me regenerate the mesh. Now there is a path that we can find. Yes, we have found, and the length is 29, explored nodes also 29. If we do the DFS path finding, here path length is 71, explored node 71. So BFS, we know it finds the shortest path. DFS finds the path, but it may not be the shortest, but BFS always finds the shortest path.